In the last section, we talked about how the slope of a line which is plotting distance versus time is the speed of the vehicle. Okay, and the reason is that the vertical distance divided by the horizontal distance is the slope. In this case, the vertical distance on this chart is the distance, it's meters. The horizontal distance on this chart is time, which is seconds. So the slope, if we just calculate it for this kind of chart, is meters divided by seconds, which is meters per second, which is a velocity. Now let's look at that some more. Here we have two different people, one riding a bicycle, the other running. The bicycle obviously is much faster than the runner. And if we look at the curve, again, of distance versus time, we'll see that the slope, that is how far the line goes vertically, that is the distance, versus horizontally, the time, is steeper than it is for the runner. And the reason for that is that bicycles obviously travel at a higher velocity than runners do. In this case, the velocity of the bicycle is 8.3 meters per second. The velocity of the runner is 2.8 meters per second. If we look at both of them plotted on the same chart, again, the blue line, which is the cyclist, has a steeper slope than the red line, which is the runner. And the reason is because the cyclist's velocity is higher than the runner's. Now, what happens if I give the runner a head start? How is that going to change this curve? So I'm going to give the runner a 4-kilometer head start. Okay? Now, what has happened here is that the slope of the runner's curve hasn't changed at all. And the reason is that the velocity hasn't changed. If I look at the distance that the runner has gone over 2,000 seconds of the chart, it's exactly the same as it was when the runner started at 0. Okay, when I'm back down here or when I'm up here, the runner covers the same distance. The only difference is that in this case, the runner started out ahead of the cyclist. In mathematics, this is called the y-intercept. And the reason it's called that is, again, very similar to the meanings of these words in normal conversation. The word intercept simply means where two things cross. In this case, what's crossing is the line of the curve and the y-axis. That's why it's called the y-intercept. It's where the line intercepts the y-axis. Now, what's magic about that is that the y-axis starts where the x-axis equals 0. And, in the same way that the x-axis starts where the y-axis equals 0. So this is telling you for the value of 0, okay, for time or whatever is on the x-axis, the y-intercept tells you what the value of the y variable, in this case distance, is. In the current case, what we're talking about, when time equals 0, that is when the two start out, the runner starts at 4,000 meters. So the y-intercept of his curve is at 4,000. If I move this back down, now his y-intercept is 0. That's all it means. The y-intercept is just telling you where the curve starts when the value is 0. However, for a line, if you think about it, if you know where it is at 0 and you know its slope, you know everything about the line. There's only one line that matches that pair of values, that is where it starts and what the slope is. And given those two, you know what the value on that line is at any point. So that's why we talk about the slope and the y-intercept when we're working with anything that can be charted as a line.